Welcome. Today, we're diving into the world of servers, the backbone of modern computing. Whether you're streaming a movie, shopping online, or sending an email, servers are working behind the scenes to make it all happen. But not all servers are created equal. There are two main types: physical servers and virtual servers. Each has its own strengths, weaknesses, and ideal use cases. In this video, we'll break down the differences, explore how each works, and help you understand which might be the best fit for different needs. Let's start by understanding what a server actually is. Server is a powerful computer designed to process requests and deliver data to other computers over a network. Think of it as a central hub that stores information, runs applications, and manages resources for multiple users. Servers can be found in data centers, offices, and even homes, handling everything from websites to file storage. The key is that servers are always on, ready to respond to requests at any time. Now that we know what a server is, let's look at the two main types: physical and virtual. Physical servers are the traditional hardware-based machines you can actually touch. They consist of components like CPUs, memory, storage drives, and network cards, all housed in a physical chassis. These servers are dedicated to specific tasks or applications, and their resources are fixed based on the hardware installed. Physical servers are often used in environments where performance, control, and security are top priorities. They require space, power, and cooling, and typically need IT staff to maintain them. Next, let's see how virtual servers differ. Virtual servers, on the other hand, are software-based. They run on top of physical hardware using virtualization technology. This means a single physical server can host multiple virtual servers, each acting as an independent machine with its own operating system and applications. Virtual servers are flexible, scalable, and cost-effective. They can be created, modified, or deleted quickly, making them ideal for dynamic environment. Now let's explore how virtualization actually works. Virtualization uses a special layer called a hypervisor, which sits between the physical hardware and the virtual servers. The hypervisor allocates resources like CPU, memory, and storage to each virtual server as needed. This allows for efficient use of hardware, as resources can be shared and adjusted dynamically. Virtualization also enables easy backup, migration, and recovery of servers. With this technology, organizations can maximize their hardware investment and respond quickly to changing demands. Physical servers offer several advantages. They provide dedicated resources, meaning there's no competition for CPU, memory, or storage. This results in consistent high performance, which is crucial for demanding applications like databases or large-scale enterprise systems. Physical servers also offer greater control over hardware configurations and security settings. For organizations with strict compliance requirements or specialized hardware needs, physical servers are often the preferred choice. Despite their strengths, physical servers come with some drawbacks. They require significant upfront investment in hardware, as well as ongoing costs for power, cooling, and maintenance. Physical servers are less flexible, since adding or upgrading resources often means purchasing new equipment. They also take up physical space and can be more challenging to scale quickly. For organizations with limited budgets or rapidly changing needs, these limitations can be significant. Virtual servers shine when it comes to flexibility and scalability. They can be deployed or removed in minutes, allowing organizations to respond quickly to changing demands. Virtual servers make it easy to allocate resources where they're needed most, and they support automation and rapid scaling. This leads to cost savings, as companies can pay for only the resources they use. Virtual servers also simplify backup, disaster recovery, and migration processes, making IT management more efficient. However, virtual servers are not without their challenges. Because multiple virtual servers share the same physical hardware, resource contention can occur, leading to performance issues if not managed properly. Security can also be more complex, as vulnerabilities in the hypervisor or other virtual machines can potentially impact all servers on the host. Additionally, some applications may require direct hardware access, which virtual servers can't always provide. When it comes to performance, physical servers usually have the edge. Since all resources are dedicated, there's no competition from other virtual machines. This makes physical servers ideal for high-performance workloads, such as large databases or scientific computing. Virtual servers, while highly efficient, may experience performance fluctuations if the underlying hardware is heavily utilized. However, for most business applications, virtual servers provide more than enough power. Scalability is where virtual servers truly excel. Need more capacity? Simply spin up additional virtual servers or allocate more resources to existing ones. This can be done in minutes without the need for new hardware. Physical servers, in contrast, require purchasing and installing new equipment, which can take days or weeks. For businesses that experience rapid growth or fluctuating demand, virtual servers offer unmatched scalability. Cost is a major factor in choosing between physical and virtual servers. Physical servers require a large upfront investment in hardware, plus ongoing expenses for maintenance, power, and cooling. Virtual servers, on the other hand, are typically billed on a pay-as-you-go basis, making them more affordable for many organizations. By sharing hardware, virtual servers also reduce waste and improve overall efficiency. Security is a top concern for any IT infrastructure. Physical servers offer strong security by isolating workloads on dedicated hardware, reducing the risk of cross-contamination. Virtual servers, while secure, require careful management of the hypervisor and virtual machines to prevent vulnerabilities. Proper configuration, monitoring, and updates are essential to maintaining a secure virtual environment. Managing physical servers often involves hands-on tasks like hardware upgrades, repairs, and routine maintenance. This can be time-consuming and may require specialized staff. Virtual servers, in contrast, can be managed remotely through software interfaces, making tasks like updates, backups, and scaling much simpler. Automation tools further streamline management, reducing the workload for IT teams. Deployment speed is another key difference. Setting up a physical server can take days or even weeks, from ordering hardware to configuring the system. Virtual servers, however, can be deployed in minutes using templates and automation tools. This rapid deployment is especially valuable for businesses that need to launch new services or respond to market changes quickly. Physical servers can sometimes be underutilized, with resources sitting idle if not fully used. Virtual servers solve this by allowing multiple workloads to share the same hardware, maximizing resource utilization. This leads to better efficiency and lower costs as organizations can get more value from their investments. Disaster recovery is easier with virtual servers. Backups and snapshots can be taken quickly, and entire virtual machines can be restored or moved to new hardware with minimal downtime. Physical servers, on the other hand, may require manual intervention and longer recovery times. Virtualization makes it possible to maintain business continuity even in the face of hardware failures. For small businesses, virtual servers are often the best choice. They offer low upfront costs, easy management, and the flexibility to scale as the business grows. Small businesses can start with minimal resources and expand as needed without investing in expensive hardware. This makes virtual servers an attractive option for startups and growing companies. Large enterprises may benefit from a mix of physical and virtual servers. Physical servers provide the performance and control needed for mission-critical applications, while virtual servers offer flexibility for less demanding workloads. This hybrid approach allows organizations to optimize costs, performance, and security across their IT infrastructure. Virtual servers are the foundation of cloud computing. Cloud providers use virtualization to offer scalable, on-demand resources to customers around the world. This allows businesses to access powerful computing resources without owning or managing physical hardware. Cloud computing has revolutionized the way organizations deploy and manage IT services. Imagine a company running a high-traffic database that requires maximum performance and security. They might choose a physical server, ensuring dedicated resources and full control over hardware and software. This setup is ideal for applications where downtime or performance issues are unacceptable, such as financial systems or healthcare databases. Now, consider a web development team that needs to test multiple websites and applications. Virtual servers allow them to quickly create, modify, and delete environments as needed without waiting for new hardware. This flexibility speeds up development cycles and reduces costs, making virtual servers perfect for testing and development. Virtual servers can help reduce the environmental impact of IT operations. By consolidating workloads onto fewer physical machines, organizations use less power and cooling, resulting in lower energy consumption and carbon emissions. Physical servers, when underutilized, can waste energy and resources. Virtualization supports greener, more sustainable computing. Physical servers require specific hardware components, such as CPUs, memory, storage, and network interfaces. These must be carefully selected and configured to meet the needs of the applications they'll run. Virtual servers, while still dependent on underlying hardware, are more flexible, as resources can be allocated and adjusted through software. Some software applications require direct access to hardware or specific configurations, making physical servers the better choice. Virtual servers, while compatible with most modern software, may not support certain legacy or specialized applications. It's important to consider software requirements when choosing between physical and virtual servers. Both physical and virtual servers rely on robust network connections to deliver data and services. Physical servers may require dedicated network interfaces for maximum performance and security. Virtual servers can use virtual networking, which allows for flexible configurations and easier management, but may introduce additional complexity. Physical servers have a finite lifespan, typically lasting 3 to 5 years before needing replacement or upgrades. Over time, hardware can become outdated or fail, requiring investment in new equipment. Virtual servers, by contrast, can be migrated to new hardware without disruption, extending the useful life of applications and services. One of the biggest advantages of virtual servers is the ability to migrate workloads between physical hosts with minimal downtime. This process, known as live migration, allows IT teams to perform maintenance, balance loads, or recover from hardware failures without interrupting services. It's a powerful tool for maintaining uptime and flexibility. Upgrading a physical server often means replacing components like memory, storage, or CPUs. This can be disruptive, requiring downtime and careful planning. In contrast, virtual servers can be upgraded by simply allocating more resources through software with little or no interruption to services. Backup strategies differ between physical and virtual servers. Physical servers often require manual backups or specialized hardware, while virtual servers can use automated snapshots and replication. This makes it easier to protect data and recover quickly from failures, especially in large or complex environments. Certain industries, such as healthcare and finance, have strict compliance and regulatory requirements. Physical servers may be necessary to meet these standards, as they offer greater control over data location and access. Virtual servers can also be compliant but require careful configuration and documentation to satisfy auditors. Redundancy is important for ensuring uptime. Physical servers can be configured with redundant power supplies, network connections, and storage to minimize the risk of failure. However, this increases costs and complexity. Virtual servers achieve redundancy through software, allowing workloads to move between hosts automatically if a failure occurs. Flexibility is a key advantage of virtual servers. They can be resized, moved, or cloned with ease, supporting rapid changes in business needs. Physical servers, while reliable, are less adaptable and require more effort to modify or expand. For organizations that value agility, virtual servers are the clear winner. Both physical and virtual servers can be highly reliable when properly managed. Physical servers offer stability through dedicated hardware, while virtual servers achieve reliability through redundancy and failover mechanisms. The choice depends on your organization's needs and resources. Physical servers allow for deep customization of hardware and software, making them ideal for specialized applications. Virtual servers offer customization at the software level, with the ability to quickly deploy different operating systems and configurations. The right choice depends on the level of customization your applications require. Monitoring is essential for both types of servers. Physical servers require hardware monitoring tools to track temperature, power, and component health. Virtual servers use software-based monitoring to track resource usage, performance, and availability. Both approaches help ensure smooth operations and quick response to issues. Automation is easier with virtual servers thanks to software tools that handle deployment, scaling, and maintenance. Physical servers can be automated to some extent but often require manual intervention. Automation reduces errors, saves time, and improves consistency across IT environments. Energy consumption is an important consideration. Physical servers, especially when underutilized, can waste energy. Virtual servers help consolidate workloads, reducing the number of machines needed and lowering overall power usage. This not only saves money but also supports environmental sustainability. Future of servers is moving toward greater virtualization and cloud adoption. Advances in hardware and software are making virtual servers more powerful and secure. Hybrid environments combining physical and virtual servers are becoming the norm, offering the best of both worlds. Staying informed about these trends is key to making smart IT decisions. Choosing between physical and virtual servers depends on your organization's needs, budget, and goals. Consider factors like performance, scalability, cost, security, and management. For many, a hybrid approach offers the flexibility and reliability needed to support a wide range of applications and workloads. Let's recap the main differences. Physical servers offer dedicated resources, high performance, and strong security but require more investment and maintenance. Virtual servers provide flexibility, scalability, and cost savings, but may face resource contention and require careful management. Understanding these differences will help you make the right choice for your IT environment. Experts recommend evaluating your current and future needs before deciding. For stable, high-performance workloads, physical servers may be best. For dynamic, scalable environments, virtual servers are often the way to go. Many organizations benefit from a mix, leveraging the strengths of both types to achieve optimal results. To future-proof your IT infrastructure, stay flexible and open to new technologies. Virtualization and cloud computing will continue to evolve, offering new opportunities for efficiency and innovation. Regularly review your server strategy to ensure it aligns with your business goals and technological advancements. Physical and virtual servers each have unique benefits and challenges. The right choice depends on your specific requirements, resources, and goals. By understanding the differences and staying informed about industry trends, you can build a robust, efficient, and future-ready IT environment. Thanks for joining us on this journey through physical and virtual servers. We've explored their differences, advantages, and ideal use cases. Whether you're managing a small business or a large enterprise, understanding your options is key to making the best IT decisions. Stay tuned for more insights into the world of technology.